Assalamu alaikum everyone. I hope you had a nice, long, and enjoyable weekend. And to start off this week, I will give you an activity. Okay, so I will show you some diagrams, and these diagrams are linked to the topic which we have been covering, traffic control devices. And you have to tell me what is shown in these diagrams and try to give me as much detail as possible. So I just don't need the title of the diagram, the things which are in the diagram. If you can tell me the detail about them, it will be much better. Okay, and it will refresh your minds as well. So we go from right to left. Okay, so the diagram on the right hand side, what does it show? This one. What does this diagram show? The diagram on the right hand side, what does it show? Anyone? Hashim, Haya, Aneen. You're going from left to right, and you have to tell me the diagram on the right hand side shows what? Parallel versus perpendicular. We don't call it perpendicular, we call them transverse. Okay, transverse marking. Okay, transverse marking, yeah. Okay, as I mentioned earlier, why I'm emphasizing that you should not call them perpendicular, because they may not be perpendicular to the center line. Okay, they may not be perpendicular to the center line like these. They are not perpendicular to the center line, but we still call them transverse. Okay, and what you called as parallel, this is called as longitudinal. Okay, the diagram in the middle, the figure in the middle, what does it show? Yes, this one. What is it showing? Transverse marking, yeah, yeah. And where are they used? Intersection marking, good, great, yeah. Not longitudinal, there are no longitudinal markings in the middle diagram. All of them are transverse. All of them are transverse. What about the picture on the left hand side? What does it show? This picture, the left hand side, what does it show? It's a regulatory sign, yes. It's a regulatory sign. Stop. It's a regulatory sign, yes, good. Okay, top right corner. Top right corner. What is it showing? Object marker. Object marker, yes. Okay, great. Then the one at the bottom, right hand side, bottom figure. What is it showing? I'm basically asking about these orange, small orange poles. What are they showing? Delineators, yes, yes. Okay, delineators. Good. Okay. The figure in the middle. The picture in the middle. What is it showing? It's a guidance sign. Yes. Yes. Great. Okay. Top left. Top left. What is it showing? It's a regulatory sign. Yeah, direction guidance sign, regulatory sign. Okay, fine. And one at the bottom, the triangular one with reduced speed. What is it showing? It's a warning sign. Okay, okay, that's great. Okay, we have two pictures now, right and left. Go ahead, whichever makes sense to you, whichever you remember, tell me, right or left. In roadway lights, the one on the right hand side is in roadway lights. Okay, and the one at the left hand side is basically showing one light. Okay, so these are two different pictures. In both the pictures, the main thing is there is only one light. What do we call it? Okay. What about the left hand side figure? Left hand side picture. Flashing beacons. Flashing beacons. Okay, flashing beacons. They are known as flashing beacons. Okay, yeah. Work zone traffic signal is when you have a work zone. It can be similar, but it's near to the work zone. Okay. Flashing beacons and both of them are what? They are type of what? Both these figures, flashing in roadway lights and flashing beacons, they are type of what? Hmm? Traffic signals. Yeah, they are considered under the heading of traffic signals. Okay. Then we discussed some equations as well last week. So I thought I should include these two graphs. So the one on the right hand side, what is this VC and C and N? What is it? What do these mean? What do these things mean? And from where did I get this graph? How did I plot it? What do you know about the graph on the right hand side? What is N? What is VC? And how did I get this graph? Yes, anyone? Have a guess. No problem. Hmm? What is N here? C is cycle length, it's written. What is N? What is VC? N is number of phases. N is number of phases, not number of lanes. Yeah, and VC is what? What is VC? What do I call VC? That is cycle length. Critical volume, maximum volume. Okay, fine. Yeah, it's written sum of critical lane volume. I know it's written, but what did I call VC? Okay, what did I call VC? VC is basically the maximum volume. The maximum volume. So we had an equation for VC, saturated volume. That's fine. Saturated volume capacity, right? Capacity. So VC is the capacity. We had an equation for capacity. In that equation, we tried different values of n, number of phases, and we tried different values of C, and then we plotted the graph. Okay. The graph on the left-hand side then. On the left-hand side. What is this graph showing? What trend is this graph showing? Why it is so high at the start, then it goes down, and then it becomes a straight line. And the value for the straight line is given as h. So what does it mean? What is the meaning of h? H indicates what? And what is this graph showing? Why the h was so high? Why it was so high earlier than it went to a straight line? H is saturation headway. Okay. Okay. So what is this graph showing then? Yeah, H is saturation headway, and what is this graph showing? Why is this high and then goes low? Okay. I think I explained the term delta as well. This delta. No, it's not the speed of cars leaving the signal. It has nothing to do with the speed, basically. There's no parameter of speed here. Because on the x-axis, you have number of cars, not distance. For speed, you need distance, right? There's no speed here. Startup loss time, yeah. Startup loss time needed for cars to leave the signal. Okay, great. That's good. Okay, so this is basically the headway between the cars which are leaving the signal, and whatever value you observe in addition to saturation headway is a startup loss time, and saturation headway is attained from the fourth or the fifth vehicle in the queue. So the headways of vehicles which were initially in the queue, the first 3-4 vehicles in the queue had extra values of delta in them, so that's why we did not call them saturation headway. Okay, so this is basically showing the trend of decreasing headway from one vehicle to other vehicle in the queue. Okay. So let us now come back to the topic which we are covering. So the last thing which we did was from the equation of VC, we rearranged it to find out the value of minimum cycle length. And then we said that we don't want the flow rate in the peak hour to be equal to capacity. So we introduced two factors, peak hour factor and V/C ratio. And then we did one example in which we saw the effect of V/C ratio on the desirable cycle length. Today we will do another example in which we will see the effect of number of lanes on the cycle length. Okay. So in this example, we have an intersection, and the volume in each direction for this intersection is given. So east-west has 1800 vehicles per hour, and north-south has 1200 vehicles per hour. They have given me some initial values for the cycle signal design, the most important of which is the cycle length, which is given as 60 seconds. So I have 60 seconds of cycle length. Loss time 4 seconds per phase. It has two phases. Peak hour factor is given. V/C ratio, it's fixed now. Okay, so we will not change it like we did in the previous example. And saturation headway is 2.3 seconds per vehicle. What they're asking me to do is how many lanes should be provided on this signal, first of all, and then using those lanes, what should be my minimum desirable cycle length. Okay, so first find out the number of lanes, and then with those lanes, how much cycle length do I require? Okay, let me go to the notebook. Okay, now the important point here is that the initial cycle length is given. Okay, so I will take it as minimum cycle length. I will take it as a minimum cycle length, that this is the minimum value. I can give this one or more than that. Okay, so if this is the cycle length, then how much VC, how much volume can it handle? If minimum cycle length is 60 seconds, then how much volume can this cycle length handle? So first of all, I will find out that. I have an equation for minimum cycle length. I have two phases, 4 seconds per phase of lost time, 1 minus VC. I'm trying to find out VC here. 3600 upon saturation flow rate 2.3. Okay, so you need to tell me the value of VC. You can keep on calculating, okay? I'm just passing the time here. $13.57, okay. 1357 vehicles per hour per lane. Okay, why per lane? Because we use a saturation headway in the equation, so by default it is per lane. Okay, so from all directions, this cycle length can handle 1357 vehicles per lane. Okay, so total per lane volume from all directions should not be more than 1357 vehicles. Okay, now if you go to the example, the volume given in east-west 1800, north-south 1200. So per lane, assuming that I will have one lane in east-west direction and one lane in north-south direction. So this total 1800 will be per lane, and this total 1200 will be per lane. So total per lane volume from both directions, assuming one lane in each direction, will be 3000, 1800 plus 1200. But my signal cannot handle more than 1357 vehicles per lane per hour. Okay, so I need to reduce this 3000 to a value which is equal or less than 1357. 1357 is the maximum my signal can handle, and 3000 is the actual value right now with one lane in each direction. Okay, so what I will do is I will increase the number of lanes in the direction which has higher volume. So north-south has 1200 and east-west has 1800. So east-west has more volume. So I will divide this volume into two lanes now. I'll divide this volume into two lanes. So per lane will become half. So come here. So this is still 1200. And 1800 divided into 2, 900 each. Okay, so I have per lane 900 in east-west direction and 1200 in the north-south direction. North-south direction. So 900 plus 1200 is 2100. So per lane volume with 2 lanes in east-west direction is 2100. Now, can my signal handle that much? No. But still, the allowable one is 1357. So I need to bring it down more. Okay. So again, I will use the same approach. I will introduce another lane in the direction which has higher per lane volume. So the direction which has higher volume is now north-south because it has now 1200 in one lane. So if I divide it into 2 lanes, the north-south direction, if I divide into 2 lanes, so 1200 will be divided into 2, right? So it will not be 1200, it will be actually now 1200 by 2, which is 600. Okay, 600 in each lane. So 600 in each lane in north-south and 900 in each lane in east-west. So 6 plus 9 means 1500. So total per lane volume for both directions is now 1500, sorry, not 16, 1500. So is it allowed? Can my signal handle that much? The answer is still no. There's still more than 3057. So I need to break it down a little bit more, but I'm very close. You can see I'm very close. So again, I should increase a lane in the direction which has higher flow. That is now the east-west direction. It has 900 per lane now. If I add one more lane here, so this total was 1800. So this 1800 will now be divided into 3. So it will become 600 for each lane. Okay, so 600 in the north-south direction, 600 in the east-west direction. Total is 1200. Okay, and now this 1200 is less than the value which is the maximum for the signal, 1357. So I can stop here. So my final design is that I can have 3 lanes in the east-west direction and 2 lanes in the north-south direction, and it will give me a volume which is less than the maximum of my signal with the initial design. Okay, so I will call this value as, let me call the initial value as VC dash, the one which you calculated, and the final value for VC with these number of lanes is 1200 vehicles per hour per lane. Okay, so this is the final value. Now this is one part of the question, which is to determine the number of lanes. So I will have 2 lanes north-south, 3 lanes east-west. The other part of the question is, what is minimum desirable cycle length with the final number of lanes? With the final design, what is the minimum desirable cycle length? So for the minimum desirable cycle length, I already have an equation, which is this one. Okay, and you can see then I need to incorporate the factor of peak hour factor and V by C ratio. These factors are given here: peak hour factor 0.95, V by C ratio 0.9. So the equation is quite similar with the addition of these 2 factors. So I'm trying to find out here C desirable. EC is now the one which you have with the final design. Okay, and then multiply by peak hour factor, multiply by V by C ratio. So give me the value for C desirable. Yes, how much is C desirable? Okay, 77.4 seconds, yeah. And you can round it up to 80 seconds. Okay, it's allowed. You can round up the cycle length to 80 seconds, no problem. Usually to the nearest 5 or 10 seconds. Okay, so this is the desirable cycle length. Okay, so before I move forward, is this clear? Is this problem clear? What I did initially with the number of lanes, especially. So initial values were given. I used it to find out VC. Okay, and then I found the number of lanes using that VC, and then using the final VC, I recalculate the desirable cycle. Okay, great. Now let's say the client puts us under a restriction that we can have maximum 2 lanes in each direction. We can have maximum 2 lanes in each direction. And this is a very common restriction, which is because of the space constraints. The space on the ground can be limited, and because of that, the number of lanes cannot be increased as much as you like. So if I have 2 lanes in each direction, so both the volumes must be divided by 2. So 1800 divided by 2 is 900, and 1200 divided by 2 will be 600. Okay, so 6 plus 9 again will give you 1500. So what will happen if VC is 1500? How much will VC desirable then? Now I don't have to, so number of lanes are fixed. So obviously VC became fixed. I cannot change it now. Okay, so now whatever value you will calculate using this value. That's it. Yeah, what is C desirable now? Minus 66.2 seconds. Now a minus value indicates impractical set of values. Okay, meaning the combination of values which you have taken to calculate C desirable is not valid, is not possible. Okay, so the example which we did last Tuesday, we fixed that problem by changing the V by C ratio. Okay, and in this example, you can see that we could have played, obviously, if somebody did not restrict us about the number of lanes, we could have played with the number of lanes as well. And we have seen in the first part of this problem that we can get a positive cycle length if the restriction for space is removed. Then we can introduce more lanes and we can find out a positive cycle length. Okay, so in these two examples, you have seen the effect of V by C ratio and VC on cycle length. Okay, and VC is linked with the number of lanes you have. Okay, now we come to the concept of critical lane. Okay, now you have seen that for every phase or for every direction, I was picking the volume from one lane in the last example. So if I had 2 lanes, I was not taking the total volume of 2 lanes, I was taking volume of one of those 2 lanes, because obviously the other lane is going simultaneously, right? So other lane is not a problem. If volume can go from one lane, the other lane will go simultaneously. In the previous example, it was a simple case that both lanes were carrying equal volume because both were for the same direction or for the same movement. But on the highways, you will find many times that there are multiple lanes and the movement of these lanes is different. So one lane is for left turning, the other one is for right turning, and there's one for straight movement as well. So as you know, the left turning movement will not be same as the straight movement, and straight movement will not be the same as right turning movement. So I have to pick one lane. In the previous example, it didn't matter, right? Because both lanes were carrying equal volume. So whether I pick lane number 1 or lane number 2, it doesn't matter. It didn't matter. But if lanes were having different volumes, then you obviously have to pick one of them for the design, and that lane from which you are picking the volume for design is known as a critical lane. So what is a critical lane? The lane from which volume will be used for design. Okay, and which lane should be chosen as critical? The lane which has more intensive traffic. The lane which has more intensive traffic. Now the term more intensive most of the times will mean the lane which has higher volume. Most of the times. Most of the times. Okay. Because in many cases, the difference between volume of different lanes is quite high. Okay, so in that case, the lane which has higher volume is the critical lane. It has more intensive traffic. But what if you have two lanes and their difference between the volume is not so high? In that case, even the lane having less volume can be considered more intensive. It can be considered as a critical lane. How is this possible? For example, you have vehicles going straight. Okay, and you have vehicles turning left. Now obviously, or vehicles turning in any direction. Most of the times, vehicles which are going straight take less time to cross the intersection as compared to vehicles which are turning. Because turning takes more time, you do it at slower speed. Straight you go at high speed and so on and so forth. And straight path is, the shortest one and so on. So many times, or not many times, all the times, turning vehicles take more time to cross the intersection as compared to straight vehicles. Then within turning vehicles, right turning vehicles take less time as compared to left turning vehicles because left turning vehicles cover a larger radius. Okay, so it may happen that you have two lanes. One lane has 700 straight moving vehicles and the other lane has, let's say, 650 turning vehicles. And that lane may become a critical lane. Although it has less volume, but because this volume was turning, it will take more time, so it will become more intensive or critical lane. Okay. Another factor can be the percentage of heavy vehicles. You have two lanes. Okay. Same volume, but one lane has 10% trucks, the other one has 6% trucks. So obviously that lane which has 6% trucks, even with equal number of vehicles, will take more time because trucks will move slowly. So since it has more trucks, so it will need more time. Okay, so the lane which has 10% trucks should become a critical lane. Okay, so more intensive is a broader term, it's a more comprehensive term, but it is directly linked with the amount of time you need to pass the flow from that lane. It is directly linked with the amount of time, not with the number of vehicles. Okay, why? Because we are designing signal. So signal is related to time. We are designing the time. So critical lane is a lane which requires more time for its vehicles to move. Okay, and like I said, in most of the cases, the difference between the volumes of different lanes is quite high. So if you have one lane which has 500 vehicles, the other one has 1100 vehicles, obviously 1100 vehicles lane will become critical because the difference is so high. 600 vehicles, so high. Okay, so with all the considerations given, the one which has higher volume will eventually become the critical lane, but not in all the cases. Okay, so like we did in the previous example, you have to pick one lane from each movement, from each phase as a critical lane. You will take the volume of that critical lane, you will add them together, that will become your VC, and VC will be used for designing the cycle length. Okay, after you design the cycle length, like we did in the last example, we got it 77 seconds approximately. So let's say I rounded off to 80 seconds. 80 seconds. Out of these 80 seconds, how much should be given for each phase, for each movement? That will again depend upon the volume in the critical lane. Okay, so volume of critical lane, if you go back to the previous example, or don't go there, because the volume became same, right? For example, one direction has a critical lane with 500 vehicles volume. The other direction has a critical lane which has 600 vehicles volume. So obviously 500 will have less time out of 80 and 600 will have more time out of 80 seconds of cycle length. Okay, so division of cycle length into different phases, again according to the volume of the critical lane of that phase. Okay, and when you are calculating startup loss time or clearance loss time, again it is calculated for the critical lane. So for startup loss time, I showed you the graph as well, and I explained last time that you have to go to the signal and then you write down the headways between the vehicles. So headways for which lane? The lane which you will be taking as a critical lane. So if you decided left turning will be the critical lane, take the headways from that lane for calculation of startup loss time. And clearance loss time, we have an equation to calculate clearance loss time, which I will show you later on. But again, that equation must be applied to the critical lane of the phase. Okay. Few important points about critical lane. So in each phase, you cannot have more than one critical lane. In each phase, there must be one critical lane. Okay, not less, not more. Okay, obviously, if you don't have a critical lane, then how can you design the timing? So there has to be a critical lane, but it cannot be more than one as well, because otherwise there will be a conflict, right? You have to take one timing. Okay, so you have to calculate timing according to one lane. So you have to decide about one lane. Which one is critical? Cannot be more than that. Okay. So if you have a total cycle length of, let's say, 80 seconds, out of those 80 seconds, in each phase, I will have some lost time. Okay, so if you subtract the lost time from the total cycle length, in the remaining amount of cycle length, at least one critical lane should be open at all times. Okay, so for example, your cycle length is 80 seconds. Out of 80 seconds, let's say the lost time is 10 seconds. So the remaining is 70. In the remaining 70 seconds, at least one critical lane from any direction should be open at all times or throughout these 70 seconds. Okay, so obviously it means that out of 70, maybe one critical lane will be open for 10 seconds, another one will be open for 15 seconds, but at least one should be open. Okay, so apart from the lost time, there should be no second in the remaining cycle length that is without a critical lane moving. Okay. And yeah, and clearance. So startup loss time means when the drivers were getting prepared to move, and clearance loss time means when what was happening. Clearance loss time is when all the signals are red. Okay. Then the overlapping phases. Okay. Now let me explain what do we mean by overlapping. Overlapping basically means when you have two phases and they have some portion of their time common with each other. Okay, so for example, if you are going from Clock Tower towards Rifa Market, the Rifa Avenue Road, on many signals, on some of these signals actually, you will find there's this movement and this movement is happening at the same time. For a few seconds, both movements are happening at the same time. Okay, this is overlapping. Okay, or if you go to any major signal, for example, the signal at Ramli Mall, okay, you will near the traffic driving school, you will find that this one and this one happens for a few seconds at the same time. Both movements are happening at the same time for a few seconds. Okay, this is overlapping. Now let me clarify something here. I said for a few seconds they are happening together, but one of them will either start earlier than the other, or may finish earlier than the other, or may start or finish at a totally different time than the other. Okay, so one of these things will happen for overlapping phases. Either for both the phases, either their start time will be different, either their end time will be different, or maybe both start and end time are different. Okay, if so, there's only one condition which is not under overlapping, which is when start and end time both are same. then you will not call it overlapping. Then you will not call these movements to be happening on overlapping phases. Then they are happening in the same phase. Okay, so this is also possible that you have two different movements happening in the same phase. Okay, why happening in the same phase? Because they are starting at the same time, ending at the same time. This is not what we call as overlapping. Overlapping is when one of them started or ended, or started and ended at different times. Okay, then this is overlapping. So if you have different movements happening in the same phase, starting and ending at the same time, then only one of them will have the critical lane. Only one of them will have the critical lane. But if you have overlapping phases, then each phase will have its own critical lane. Right? Each phase will have its own critical lane. So if you have, let's say, 2 lanes in this direction, 2 lanes in this direction, so one of these 2 lanes will become critical here, and one of these 2 lanes will become critical on this side. So you will have 2 critical lanes then. In overlapping phases, you can have more than one critical lane because each one is treated as a separate phase. If start and end time of different movements are the same, then you will consider it as only one phase, and then in that case, like I mentioned for the first point, each phase can have only one critical lane. Okay, so movements which have same start and end time, even if they are in different directions, you will consider them as part of one phase, and each phase can only have one critical lane. But coming back to the discussion of overlapping phases, if you have overlapping phases, then you may be faced with multiple options which overlapping you can adopt. Okay, so for example, first of all, make sure that the overlapping or the movement which you are allowing in the same phase, they are safe. Okay, so for example, this left turning cannot be allowed with this overlapping, right? This will be wrong. This is unsafe. This is having a conflict. So overlapping or allowing different movements in the same phase must go through the check of safety, first of all. Okay, this is the first thing you do, that overlapping or having different movements, allowing different movements in the same phase cannot be conflicting, cannot have conflicting movements. So first check is this. Even after this, you have, for example, you can see at least 2 options here. Let me call it option 1, and let me call this one as option 2. Both overlappings are allowed, they are safe. Which option should I choose? Again, it will depend upon the summation of critical lane volumes in both the options. So for example, the critical lane for this phase has 1000 volume, and this one has 1100. So total is 2100. Okay, and in this case, it's the same lane straight going towards north. So this has 1000 and this one has 700. Okay, so if you sum the 2 volumes, you will get 1700 with option 2 and 2100 with option 1. So obviously this overlapping is more beneficial than option 2. Okay, so you will go with option 1. And again, this addition of volumes of 2 critical lanes can only happen if you were talking about overlapping phases. Okay, so if both movements were happening at the same time, this will be called as one phase, and then you have to adopt one of them as a critical lane. The other one doesn't matter then. Okay, so this whole choosing the right option is for overlapping phases. Okay, now earlier when we were discussing multi-lane highways, freeways, and 2-lane highways, we talked about their measures of effectiveness, the things which we use to calculate their level of service and capacity. Those were basically flow, speed, and density. Right? Flow, speed, and density, we were using them in different equations to calculate the level of service and capacity. Now these measures of effectiveness do not work on intersections. Why? Flow is stopped on the intersection. Speed, flow is stopped means speed becomes 0. Density is for a segment, but intersection is a point. Density means vehicles per mile. So on a point you cannot have vehicles per mile. Okay, so it has to be the density cannot be used on intersection as well. So on intersection, we calculate the level of service and the effectiveness of the intersection in terms of delay, queue, and stops. In terms of delay, queue, and stops. Delay basically means the difference between the time which you consume in passing or traversing the intersection. And that is basically the difference between your arrival time and departure time. Arrival time and departure time. Okay. So arrival time is what? Arrival time is when you come towards the intersection and you stop or join the queue. That is your arrival time. So you came to the intersection, the signal was red, you stopped at the front of the queue. That is your arrival time. Okay. And departure time will be when you cross the stop line or when you reach the other side. If you are turning, then when you reach the other side, if you are going straight, then when you cross the stop line, that is your departure time. Okay. If you had come in a time when there was a queue in front of you, so your arrival time will be counted when you will join the queue. When you will come directly behind the last vehicle of the queue, that will be your arrival time, or your departure time will be the same when you cross the stop line and when you reach the other side. Okay. So if you came towards the signal and the signal was green and there were no vehicles in front of you before the stop line, then you will just come and cross the stop line. So then your arrival and departure time is the same. Delay is 0. Delay is 0. Nobody was in front of you. And the signal was green. You didn't stop. Okay. You didn't join the queue. You didn't stop. In that case, your delay is 0. Okay. The queue is defined as the number of vehicles which are stopped in the queue behind the stop line, and stop is how many vehicles are stopped because of the queue, or the percentage of vehicles which are stopped because of the queue or the signal. Okay, that is stop. So these are the measures which we use for effectiveness of the intersection. Out of these measures, delay is the most common one, and there are 4 types of delays. Okay, there are 4 types of delays: stop time, approach delay, time in queue delay, and travel time delay. Now, stop time, very simple. The name itself defines it. The time when you were stopped. The time when you were stopped. So when you came to the intersection the amount of time for which you were stopped becomes your stop delay. Then we have approach delay. We have already defined approach delay with a different name earlier in travel time studies. We called it control delay. So control delay and approach delay are basically the synonyms of the same parameter. Okay. And how did you define control delay? Control delay starts when you decelerate for joining the queue or for coming towards the intersection, and it ends when you accelerate to your desired speed. Okay, so control or approach delay, it starts from the point of time when you start decelerating, and it is till the time when you accelerate to your desired speed. Okay, so during this time, you will come, there's a queue in front of you, you will decelerate, you will join the queue, you have to stop for a few seconds, and then when you cross the stop line, you start accelerating back to the desired speed. And all these things are included in approach delay or control delay. Okay, then we have time in queue delay. Time in queue delay, and we had an equation for calculating time in queue delay with the travel time studies. Okay, now you may say why? So time in queue delay means when the vehicle was in the queue, right? Now your question can be, if you are alive and awake, your question may be that why we have 2 different terms, stop delay and time in queue delay. Isn't it the case that the vehicle has to stop in the queue? And my answer is no. It may not be the case that the vehicle has to stop in the queue. Queue can be moving as well. Queue can be moving as well. Okay, you are considered part of the queue even if you are moving till the time you have crossed the stop line, or till the time when you were turning and you have reached the other side. Till that time you will be considered in the queue. Okay, so for some time you may be stopped, and then for some time you may be in the queue but moving. So the time when you were stopped is stop delay, but the time when you were moving but still you didn't cross the stop line or you did not turn to the other side, that is also time in queue delay, but it will not be considered as stop delay. Okay, so this is the difference between them. Then we have travel time delay. Travel time delay is the difference of actual travel time and desired travel time for crossing the intersection or for crossing any road segment. Okay, now actual travel time can be observed. You go to the intersection, note down the time for the vehicles to go from one side of the intersection to the other side. Okay, from their arrival to their departure time, you can note down the actual travel time. Desired travel time comes from the free flow speed. Desired travel time is a travel time which you will calculate using the free flow speed, or which you will observe when the driver was going at free flow speed. Okay. Now, how to find out the free flow speed at an intersection? I have briefed the method earlier as well when you were doing travel time studies. So this will be my first question tomorrow. This will be my first question tomorrow with you or to you, that how do we find out the free flow speed of a segment which is ending at an intersection? Okay. So if you give me the answer, I will tell you it's right or wrong. If you don't give me the answer, nobody gives me the answer, I will just skip it and I will go to the next topic. Okay. So tell me, you have to tell me tomorrow how to find out the free flow speed of a road segment which is coming towards an intersection. Okay. And just a hint, there are two methods to do it. Okay. Even if you tell me one method, I will revise it. Okay. I will revise the whole thing. But if you are silent, then I will be silent as well. Okay. Any questions? Everything is clear? Okay. Okay. Thank you. You are welcome. Have a nice day. See you guys tomorrow, inshallah. Assalamu alaikum.